Hi students, now we are going to start new chapter. Chapter name is haloalkane and haloarene compounds. This is the chapter name haloalkanes, haloarenes. In this, the carbon we take the alkanes, that means there is a hydrocarbon compounds. So we take the hydrocarbon is C carbon, main component, element is carbon. Carbon valency is 4, tetravalency, this have 4 bonds. Hydrocarbon we call as hydrocarbon, so that means it contain hydrogens, so we call it this is a hydrocarbon. In that one of the hydrogen position replaced with halogen, that is haloalkane, hydrogen, halogen. Okay, so this is a haloalkane, and also same like benzene C6H6. Okay, C6H6, 6 carbon, 6 hydrogens is there. In that hydrogen position replaced with halogen, we take haloarene. This is a X, remaining hydrogen. This is C6H6. We take this in this C6H5Cl. So one hydrogen position replaced with a halogen is there. Okay, that is a X. So we take this is a haloarene. Okay, so now we are going to start its classification and its nomenclatures. Okay, before that, these haloalkanes and haloarenes are covalent bond is formed between the carbon and halogen. These compounds are not available in free form in nature, but chemically synthesized. These compounds are useful for introducing alkyl aryl groups in the organic compounds. Okay, and these haloalkane and haloarene compounds are good solvents, and these compounds are useful in obtaining immunity against disease in human body. Secretion in biochemical reaction in hormones. So for example, iodine in thyroxine. Okay, so and some of the compounds are used for anesthesia point of view. Anesthesia, that is chloroform. So this is one of the drug. This drug is used for the anesthesia, and most of the drugs are used as remedy of diseases like typhoid, malaria, like that. So these haloalkanes and haloarene compounds are very important in everyday life and industries. Classification on the basis of nature of halogen atoms. So these haloalkanes and haloarenes are classified into on the basis of number of halogen atoms. For example, we take halogen bonded with one alkyl group, that means one alkyl bonded with one halogen, that is monoalkane. So what is the classification based on the number of halogen atom? How many number of halogens are bonded to the carbon? One halogen, that is monohaloalkane. For example, we take CH3, CH2, Cl. So in that how many chlorides is there in this? One chloride. So this is a monochloro, 2 carbons, monochloroethane, 2 carbons. Okay, and in this you observe how many halogens are present in these 2 halogens. So 2 halogens we called as dihaloalkane. So we take this one is a alkyl group. This is a alkyl group. Okay, dihaloalkane. So for example, CH2 single bond, CH2 Br is there. So this is a 1 2 1 comma 2 dibromo 1 comma 2 dibromo ethane 1 comma 2 dibromo ethane. Okay, and next RX3, that means three halogens are bonded to the alkyl groups. So that is a trihalo alkane 3 trihalo 1 2 3 3 carbons, and every carbon bonded with one halogen. This is a 1 chlorine 1 chlorine 1 chlorine. So numbering 1 2 3. So 1 comma 2 comma 3 1 comma 2 comma 3 trichloro 3 propane. Okay, this is for alkyl groups, haloalkanes, and next we go for haloarine point of view. So this is a benzene. Benzene, one of the hydrogen position substituted with halogen. Okay, halogen. For example, we take this halogen position as chlorine. That is a chlorobenzene. Chlorobenzene. This is C6H5Cl. Okay, chlorobenzene. Monohalobenzene. Actually, this is a monohalobenzene. Okay, monochlorobenzene also you take. Dihalobenzene. Two halogens are bonded to the benzene. Okay, that means the two hydrogen positions substituted with the two halogens. Okay, so you observe in this. This is a 1 comma 2 position. This is 1 2 3 4 1 comma 4 positions. So you observe in this. For example, halogen position bromine 1 comma 2 1 comma 2 2 bromines 1 comma 2 dibromo benzene. You take this is a C6H4Br2. Okay, this is also same C6H4Br2, same molecular formula but different structure arrangements. So this is a one type of the isomerism. Okay, so you observe in this is a 1 2 3 4. So this is a 1 comma 4 positions. This is the 1 comma 2 positions. So in this 1 comma 4 dibromo benzene. Okay, 1 comma 4 dibromo benzene. This is both one content, same molecular formula but different structural arrangements. So this is called as isomerism. Next one is trihalobenzene. So in this three halogens are bonded to the three hydrogens of benzene. I mean three halogens are bonded to the benzene in the place of three hydrogen positions. Okay, so we take the example to 3 chlorines. So this is a 1 2 3 4 5 6. So this is a 1 comma 2 comma 4 1 comma 2 comma 4 trichlorobenzene. So its formula is C6H3Cl3. Okay, so this is a trihalobenzene, that is 1 comma 2 comma 4 trichlorobenzene. Okay, so this is the classification based on number of halogens. Next one is halogen attached to the carbon possessing sp3 hybridization in halogen containing organic compounds. That means halogen bonded to the carbon has sp3 carbon. Okay, so in this also some types is there. So in that one is 3 types. First one is haloalkane or alkyl halides. Haloalkane or alkyl halides. In that we take the first one is primary. Okay, so RCH2X is there. You observe in this halogen bonded carbon bond with one alkyl group, that is called as primary. Okay, so you observe in this primary. The chlorine bonded carbon bonded with one methyl group only. So this is the primary haloalkane, primary chloro 1 2 carbons ethane, or primary bromo ethane. Okay, this carbon is which type of carbon? Primary carbon. This is a primary carbon because of this carbon bonded with one alkyl group only. If the carbon bonded with two alkyl groups, that is a secondary position. This position, carbon positions is the secondary position. So we take the secondary halo alkane. Okay, commonly we call secondary halo alkane or secondary alkyl halide. We take one example in this X plus chlorine. So this is a secondary. This position is secondary. 2 chloro. 1 2 3 carbons propane. IUPAC point of view. 2 chloro propane secondary positions. So chlorine bonded with which of the position? Secondary position. And the halogen bonded carbon contain all are alkyl groups. 3 alkyl groups. 3 alkyl groups are present. So this carbon position is tertiary position. Tertiary. Okay. Without any hydrogens are bonded. No hydrogen is bonded with this halogen bonded carbon. So this is a tertiary. Actually carbon valence is 4. One of the position is halogen is there. Remaining 3 positions, 3 alkyl groups. Okay. So 3 alkyl groups are present. So we take the R3Cl. So this is tertiary position. So we take the tertiary halo alkane or tertiary alkyl halide. We take one example halogen position with chlorine. So tertiary chloro. Okay, tertiary 1 2 3 4. Tertiary butyl chloride commonly we called as tertiary butyl chloride. And we take an IUPAC point of view. This is a 1 2 3 or 1 2 3. Anyone is same. So you take 1 2 3 third position. So third 3 carbons. In the second position is chlorine and methyl group. So you take the chlorine first. 2 chloro 2 methyl propane. Okay. So what is the halogen bonded carbon position? Tertiary position. This is tertiary position. Next one is alkyl halides completed. Next one is allylic halides. Allylic halides. That means halogen bonded with a double bond attached sp3 carbon is called allylic position. What is the mean? Halogen bonded with a double bond attached sp3 carbon. Okay. So this sp3, this is a carbon position is sp3 carbon. This carbon is sp2. This carbon is sp2. So halogen bonded to the sp3 carbon. So this is bonded to the double bonded attached carbon. That means the sp3 carbon bonded with double bonded attached carbon. So this halogen is going to bond with this sp3 carbon. That is called as, this position is called as allylic position. So the type of halides are called as allylic halides. Okay. I once again repeat this one. Halogen bonded with sp3 carbon. Adjacent of sp2 carbon is there. Okay. Halogen bonded with sp3 carbon. Adjacent of sp2 carbon is present. So the type of halides are called allylic halides. Allylic, this position is allylic position. We take one example in this CH3, CH double bond, CH single bond, CH2, Cl. So in this is a 1 2 3 4 double bond position is preferably from this or this one. Both one have the same second positions. You take from this 1 2 3 4. So in this 1 chloro 1 2 3 4 carbons, 1 chloro but second position 2 in, 1 chloro but 2 in. In this you observe cyclohexene. So bonded in that hydrogen position. So hydrogen position replaced with halogen. And you observe this is a sp3 carbon. Adjacent of sp2 carbon is present. So that means it is a which type of position? Allylic position. Which type of halide? Allylic halide. So in that numbering as per the IUPAC point of view 1 2 3. Okay. 1 2 3 4 5 6. Okay. So you observe in this third position. So 3 halo cyclo hexa 1 in, first position double bond is there. 3 halo cyclo hexa 1 in, first position double bond. Okay. For example, you take chlorine halogen position. You take that 1 2 3 4 5 6. Okay. Double bond is preferable. So this is a 3 chloro cyclohexa cyclohexa 6 carbon cyclohexa 1 ene, or 1 3 chloro 1 cyclohexa 3 chloro 1 cyclohexa 1 ene, 1 cyclohexene R. Okay, next one is alkyl halide completed, allylic halide completed. Next one is a benzylic halides. Benzylic halides. Benzylic halides, you observe the carbon bond, the halogen bonded with sp2 carbon, halogen bonded with sp3 carbon, adjacent aromatic sp2 carbon is there. Okay, halogen bonded with sp3 carbon, its adjacent aromatic sp2 carbon is present. So those type of halides are called as benzylic halides, and this position is benzylic position. Okay, halogen bonded with sp3 carbon adjacent of halogen bonded with sp3 carbon adjacent of its adjacent have sp2 alkyl aliphatic sp2 carbon is present. Okay, halogen bonded with sp3 carbon, its adjacent aliphatic sp2 carbon is present. So these type of halides are allylic halides, and in this halogen bonded with sp3 carbon, its adjacent aromatic sp2 carbon is present, aromatic sp2 carbon. So these type of halides are called benzylic halides. Okay, we take an example, and what is the position, this benzylic position, and this is a alkyl group, but one aryl group is there, so it is a primary position. Okay, and you take that example halogen position with chlorine. So this is a benzylic position or benzyl position, so we take this is a benzyl chloride. Okay, and you take next secondary. Why we called secondary? This carbon have the bonded this carbon bonded with halogen, and remaining two different groups are present in this, so this is a secondary. Okay, secondary, you take the example in this. So this is a 1 chloro ethyl benzene, 1 chloro ethyl benzene. Okay, so this is a benzylic halides. And next tertiary, this carbon bonded without carbon bonded with the halogen and without hydrogens are present in this. There is no hydrogens are present in this carbon. So this is a tertiary carbon, and this type of halide is benzylic halide. So, and you take example in this. This is a 1 chloro 1 methyl 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 ethyl benzene. Okay, 1 chloro 1 methyl 2 carbons ethyl benzene. Okay, next one is classification. Third, halogen attached to carbon possessing sp2 hybridization in halogen containing organic compound. So what is the meaning of that? Halogen is directly bonded with sp2 carbon is called as vinylic position. So vinylic. So halogen directly bonded with sp2 carbon. This is, so this we called as this is a vinylic. Total how many types? First one is allylic. Next one is benzylic. Next one is vinylic. So also you represent like this. This is also vinyl chloride. Okay, vinyl chloride. This position is vinylic position. And in this you observe this halogen, this chlorine directly bonded with sp2 carbon. So this position is vinylic position. So that is 1 chloro cyclohexa 1 ene. 1 chloro cyclohexa 1 ene. Okay, and halogen directly bonded with aromatic sp2 carbon. Halogen directly bonded with aromatic sp2 carbon. This is a sp2 carbon but aromatic nature. Halogen directly bonded with aromatic sp2 carbon, that is a aryl halides. So we take the we take name is hollow benzene C6H5X. Okay, we take an example in this C6H5Cl. C6H5Cl, this is a chlorobenzene. Okay. You observe in this CH3Cl chloro halo alkane chloro. You take what is the halogen in this? Chlorine. So chloro halo chloro alkane, that is methane, chloromethane, IUPAC name. And common name alkyl halide. Which one are called? Methyl halide. Halide is chlorine. So methyl chloride. And this is a CH3CH2Cl. So this is a chloroethane, and commonly we call ethyl chloride. Okay, and this is a in this IUPAC point of view, we take the numbering 1, 2, 3. So second position is chlorine is there. So 2 chloro, second position 2 chloro, 3 carbons propane, 2 chloro propane, or iso. Commonly we called as this is a iso. So chlorine bonded position. So this is called as isopropyl chloride. Okay, isopropyl chloride. And this one bromine bonded with 1, 2, 3, 4 carbons and directly bonded with first carbon. So this is a first position 1, 2, 3, 4, 1 bromo, how many carbons? 4. So 1 bromo butane. And this is a IUPAC name, and common name is N-butyl. So this is a bromine directly bonded with first carbon, and for long chain is there. So we take N-butyl bromide. Okay. And also we take some example in this CH3, CH, CH2, Br in this CH3. You observe in this bromine bonded with first carbon 1, 2, 3. 3 is there, 3 carbons, and second is the branch methyl group is there. Okay. So this is the you observe in this IUPAC point of view, first position bromine is 1 bromo, 2 methyl, 1 bromo 2 methyl propane, 1 bromo 2 methyl propane. Okay. And next also in called as a IUPAC common name we called as isobutyl bromide. Okay. CH3, CH, single bond, CH2, CH3. In this position bromine is bonded. Okay. So this type of we take the 1, 2, 3, 4 long chain, 2 bromo, how many carbons? 4 carbon, 2 bromo butane. And commonly we called as this carbon position is 2 methyl groups are 2 alkyl groups are present. Halogen bonded carbon have the two alkyl groups are present. So we take this is a secondary butyl bromide. Okay. CH3 double bond CH2Cl. So this is a IUPAC point of view chloroethane, but commonly we called as vinyl chloride. Okay, vinyl chloride. Okay, and some aromatic compounds. Benzene bonded with chlorine. So this is a chlorobenzene, haloalkanes, chlorobenzene, and commonly we called as phenyl chloride, alkyl halide, phenyl chloride. Okay, and also you take another example CH2Cl, C6H5CH2Cl. So this is a chloromethyl benzene, benzene. Okay, and commonly we call as, this is a, what is the position? Benzyl position, benzyl. Okay, benzylic position. So we take benzyl chloride. Okay, so this is a nomenclature of haloalkanes and haloarenes.